Good afternoon, everyone, on this glorious day. Happy for you to join us in this latest BARA Webinar, Mobile Industrial Robots, a Starter Guide to Solutions and Successful Implementation. We've got together an amazing panel for you all, which I'll introduce in a moment. But first of all, I just need to go through a few housekeeping rules. And I'm going to be like Chris Whitty and say, next slide, please. Today's webinar session, you need to know, is being recorded. All of our attendees' mics have been set to mute by default. Oh, it's back. When a panelist is ready to speak, please use the mute button to unmute yourself. We encourage audience participation, so please use the Q&A button to ask any questions, and we'll try to get through as many as we can. Please do not post website URLs or company promotion in the chat box, as this will result in removal from the webinar, which would be your loss, obviously. Chatham House rules applies, and a show reel from today's event will be available on the BARA website at bara.org.uk, along with an accompanying press release. Now, the press release will be around by the end of this week, and the recording will take, after they've highlighted out and edited out all the rubbish bits, that will be there in a couple of weeks. So please wait until the session is ended by the host, and then you'll find a short feedback survey. It'll pop up on your screen, and it really would help us if you could fill this in so that we can tailor all our future events to meet the needs of the kind of information that you're after when you come to a BARA webinar. So thank you very much for that. I think we're ready to go. And I've got my panel up on screen. Here we all are. First of all, my name's Gail Hunt. I'm editor of the PPMA's Machinery Update magazine, and I'm happy now to let the panel introduce themselves, and I'm going to start with Ross Lacey.
Good afternoon. Hi, I'm Ross Lacey. I am the Mobile Robot Product Manager for RAR UK Automation. We specialise in collaborative robots. My role specialises in the mere mobile robots, and I've been Mobile Robot Product Manager since 2018.
Thank you very much. Now we're going to go on to Andy McFadden.
Hello, my name's Andy McFadden. I'm a solutions consultant at Iconsys. We specialise in automated industrial solutions. I've been with Iconsys for about 5 years now, and I look after the robotics strategy.
Fantastic. And we're coming now on to Paul Smith.
Hi, good afternoon, everyone. Paul Smith. I've been with RM Group since April this year, but I've been tooling around warehouses with lift trucks and automation since the mid-90s. So RM Group, I look after mobile automation and end-of-line systems.
Brilliant. We're coming on to George Brown.
Good afternoon, everyone. I'm George Brown. So I work for Omron Electronics in the UK. I'm currently a team leader for the Applications Solutions team, specialising in robotics, safety and vision. Prior roles has been involved with robotics application support as well. So been dedicated to kind of typical fixed robots, collaborative robots, but also mobile robots too. So happy to share my experiences with everyone here.
Excellent, thank you. And now on to Matt.
Apologies, still on mute. So I'm Matt Rollins. So I work for ABB Robotics. I worked for ABB for around six years this time around. Previous to that, I was with ABB for around 4 or 5 years at the start of my career. I look after the AMR. So I'm an AMR specialist. So the AMR portfolio, which covers many different types of AGVs and AMRs.
Excellent, thank you. So I think you'll agree we've got a panel that really does cover the whole range of technology in this area. And so obviously everyone loves an acronym. So what we're going to do is, for people who are sitting here thinking, I don't know the difference or what's going on with these, we thought we'd just go through a quick explanation. And we're starting off with George has stepped up on this. So over to you, George.
Yeah, so an AGV and an AMR, the most important thing is that they do the same job, but in different ways. So an AGV, by definition, is an automated guided vehicle. So this is a piece of technology that will move from one location to another, and it will follow a predefined route. So usually along maybe a magnetic tape, or some it might be some infrastructure in the ground one way or another. Whereas an AMR, which is a autonomous mobile robot, this again goes from A to B, but it uses an autonomous route. So it uses its live environment that it can see through laser scanners, LiDARs situated around the robot itself, or other sensing technologies like 3D cameras, to direct its route around an environment. So if there's an obstacle in the way, it can divert around it to still get to the end location without having to go through every kind of stop along the way as well.
Thank you very much. Now, I think we have Paul, you were going to talk about mobile forklifts, because I think we talked about those in the introduction to this.
Yeah, we did. So a mobile forklift pretty much would cover what we would call a dual use or a dual control. So that generally means taking a manual lift truck and modifying it with a kit, if you like, of an AGV control system and localization technology as well. So they're still AGVs, but you can hop on and off them and perform manual tasks. You'll take over when the AGV is not capable of doing something or what have you. So they have a bit of flexibility. They come with their own challenges and they come with their own clear benefits. But yeah, usually based on a standard bit of lift truck equipment.
Okay, brilliant. Thank you very much for that. So, right, before we go on to the main differences, we're basically just going to concentrate now on AGVs just for a moment. And we're going to talk about the industries and applications. If you're sitting there wondering whether your plant or your factory is suitable. So we're going to talk about AGVs first, and we're going to come to Matt first on AGVs.
Hi, thanks, Gail. Well, thanks, George. I think that was a really good brief overview. I think what I'd like to add to that is the fact that people get hung up on whether it's an AGV or an AMR, but it really doesn't matter. They ultimately all do the same job. I think it's more than the application. For me, it's the environment that you're operating in. One of the things that you see, if you have a clearly defined area, we see it a lot in automotive, where we have very organized areas where you have fixed machines, fixed objects that you can take reference points off, and the environment doesn't change. AMRs can be a very good solution. AGVs require some kind of infrastructure, be it a magnetic tape that can be in the floor or sat on top of it, or even QR codes, so it goes from one QR code to another. I think one of the advantages of the AGVs in applications that we'll see, so in automotive, where you're following a track and you're going from one position to the next, where an AGV can be very useful, is that you know how long it takes to get from A to B, because it is always following that route, and it will always it doesn't divert off that route, so it can be beneficial for those kind of applications.
Okay, thank you very much. Now, Paul, you were going to talk about AGVs, I think, as well, if there's anything left.
I think Matt's pretty much covered it. Yeah, I've got nothing to add to what Matt's just gone through.
Oh, well, excellent,
Yep.
excellent. I like it to be clear. So let's move on to AMRs. And Ross, you were going to talk about AMRs in terms of industries and applications, and then I'm going to come to you, Andy.
Thank you. I think what we see is AMRs are suitable for an incredibly wide range of applications and a huge range of industries. We have AMRs deployed in the automotive industry, aerospace, with pharma, electronics, food and beverages, warehousing, healthcare, hotels. It's literally anything that wants a product moving, any industry that wants a product moving is where we can apply the AMR technology. Probably the most popular types of applications that we see are for pallet distribution, picking up a pallet from goods inbound, delivering that to a warehouse area, or taking it from a stores area to an outbound area. We see huge interest in tote box movement within automotive areas, so gravity feeding lines, We also see a huge interest this year, actually, with using AMRs with a mobile robot with a robotic arm on top. So for machine tending, for pick and place applications, for inspection applications. So that's really a growth that's really come within the last 18 months, 2 years, really, I would say.
And why are people going for that then, with the collaborative robot?
Flexibility. So makes it really easy to use one solution to tend 5 or 6 different machines, to be able to be really flexible, pick multiple products up from around the factory. Gives a whole new way of looking at a solution, really.
Okay, thank you. Andy, anything to add now to the AMR?
Yeah, just to go on the back of what Ross said there, the word he said, flexibility. And I think that's one thing they do give you. If you've got an application or a process which is a bit more dynamic, where you've got multiple drop-off points in different places across your facility, they allow you to be a lot more flexible in the way that you can program them, and they don't have to follow the same route, and they can be dynamic in the way that they move around the factory. And I think it gives you a lot more of a flexible process.
Okay, thank you very much. Now, I know we've got our own.
Gail, sorry.
Paul, come back,
yeah,
come back.
Yeah, I'm coming back. One thing I don't think we've just covered throughout all of that is more of the wilder edge cases that I'm sure most of us have been asked for, and they revolve, I guess, more in the AGV space, but it's things like, you know, loading trailers, going through dock levelers, going outside, those kinds of things. And when you look at application requests, it's something that, you know, the marketing is really good at. You know, within the ABB range, we have an outdoor tow tractor, but, you know, it's subject to quite strict weather requirements. So we do really need to look at anything. If you've got a process you want to automate, the bottom line there is, what's your manual lift truck driver operating? And if they're making lots of little adjustments, movements, you know, little sort of movements with the load left and right, they're sort of looking around, that's probably not going to be a great automation candidate. Not right now. Give it another 5-10 years, we'll have the software smarts, the onboard computing to get there. But right now, it's those sort of environmentally difficult challenges, as well as, you know, humans are still really good at moving machinery.
Sure.
And it's those really, those edge cases that, yeah, if I had a penny every time that we went to see one, I wouldn't be on the webinar.
I think also just to add to what Paul said, the outdoor AGVs, again, it gets asked an awful lot, and in theory it's possible, but the biggest problem we have in countries like the UK is we get cold weather, it gets icy, and an AMR or AGV, if it slips on the ice and it crashes into something, we've got that whole legal quandary of who's responsible.
Okay, well, good, because we've just had some questions about using AMRs or AGV in agriculture for production of things like baby leaf salads, indoors and outdoor growing, but also talking about, are they basically better in an indoor environment rather than an outdoor environment?
We would prefer an indoor environment, but even then you've got things like humidity. So, and if it's condensing humidity, you get things on sensor lenses, and I always say to people, for sure I can do what you're asking me once. I might even be able to do it 100 times. Can I do it 1,000 times and have it operationally reliable? That's a different question, and much more.
So are you agreeing with that, George, that basically we're talking about indoor technology right now, but maybe in the future?
100%. Yeah, I think the technology or like the navigational skills there, but it's not just the navigation, it's the real life environment which really makes an impact. You wouldn't want to, I suppose, drive a forklift truck in a farm a lot of the time. You'd probably be scared and probably ruin the farm and things as well. So there's a lot of factors we want to, I suppose, as the technology is really starting to adopt, is to really get a good understanding, a good baseline of where the applications really are to start with, and then use our learnings from that to start to develop further and further as technology advances. Exactly as Paul says, the capabilities will get there, but right now, I think it's best to be to be sensible and make sure we're doing things where it is an investment and we want to do it right. We don't want to take too many big risks in it.
Sure.
But
Okay.
even in internal kind of indoor environments, there still are restrictions as well, harsh environments, wet environments, that the best thing is to have a conversation with the manufacturer, with the integrator, because they'll have the best advice for that and be able to tell you whether it's a realistic option or whether it might just be that some practices might be needed. If it's we've had inquiries about indoor farms. Yes, the floor leveling, everything might be okay, but it might just need a sweep every day from an operator kind of thing to make sure that it runs a full life, rather than, exactly as Paul said, 100 times and then it starts to fail.
Yeah.
There's a balance between the two, and that's where hopefully approaching the panel here for some expertise really adds value.
Sure. So we're talking about the kind of challenges that need to be considered, and obviously we've talked about outdoors, possibly not yet. Harsh environments pose some questions. I'm thinking about frozen foods and whatever. I'm not sure, you know, that there's all kinds of different environments that you have to operate in, isn't there? But what challenges do you think, and this is I'm going to go around the panel here, need to be considered when choosing a solution? And then I'll come back. Are they easy to clean? We've got a question, but I'll come back to that. Right, let's first talk about what the challenges need to be considered when choosing a solution initially. And I'm going to come to Ross for that first.
Again, I think we've touched on it quite a lot. It's always application dependent for what solution you really want to look at, what you want to move, how often you want to move something, the frequency, the environment. But the considerations, I suppose, are really taken into account are how much space you have, which some customers that we come across expect you to be able to move large products through very small spaces, which a person might be able to do, but a robot will struggle to do. So space really needs to be considered. We'll probably come on to it a bit later, but when you're looking at implementing a mobile robotics solution, the Wi-Fi setup on that plant needs to be fantastic. And
Right.
Wi-Fi on customer plants at the moment, no matter what the customer tells you that it's fantastic, it will not be good enough. So that's the biggest consideration for us, I think, space and Wi-Fi. And general conditions, general behavior. So we see when you first implement AMR solutions, making sure that your staff are on board as well and not blocking the routes by putting boxes down and trapping the robots in certain areas, which we've had before. Making sure that, you know, if a logistics route is specified that no box can be placed in that area because that's where the AMR goes to sit when it's got nothing to do, we need to make sure no box is placed in that area. So it's discipline that needs to be brought onto the customer site as well. That's not necessarily been needed when they haven't got robotics on site. Floor conditions as well, you know, wet floors, greasy floors, the robots are specified to stop at a certain distance in perfect conditions. You bring a greasy floor into that equation, and then that changes your risk assessment on that totally. So most importantly, space and Wi-Fi and the conditions around it. But from our experience, customers that have never used AGV AMR type of technology before, it does take a little bit of work with the staff just to make sure everybody's on board and no one's scared of the technology, no one's fighting against it. So you have a lot of we had a lot of applications that we started with the logistics team were very much against the technology and were, you know, maybe thought that it was going to replace them in the long run, but it turns out that it's actually just there to help, and it's there to take away any non-value added tasks from the environment. So it's onboarding and making sure that the staff are onboarded and brought into that ethos and understanding that they're there to help.
Okay, thank you. Andy, someone said here about, you know, if you do have dirty floors and, you know, dirty environments, does that limit the use of using this technology, do you think?
I don't think it does. I think it just generates another set of PPMs, really. So if you take an industrial robot that's been running in a car plant for years, generally you can put them in and leave them and they'll just continue to run. whereas an AMR requires a different outlook, because obviously you've got the uses the sensors for navigation and the safety. They're exposed, and I think the worse the environment, I just think the higher the upkeep, or the more often you should be doing PPMs and wiping sensors down and looking after them, really. I think it's just taking a different outlook.
Okay, thank you. Right, okay, so we're coming on to now. Have I missed anyone out? Does anyone want to talk about the challenges that need to be considered? I don't think I talked.
Got one more. I think Ross touched on it really briefly, but it's getting decent data. So about, and this comes down to what it is that somebody wants to do.
Okay.
And you know, if you're going to plan an AMR and AGV system, you need to know, you know, what the flows are. Where are you going to pick stuff up from? Where are you dropping it off to? What does that look like? But critically, also the numbers of movements that you're going to be doing on each one of those. And I'm sure we've all been in that position where you can ask, you know, some large companies, the theoretically decent, you know, internal reporting systems, and, you know, they just don't know the answers. And it's very difficult to, you know, provide a size of a fleet if you don't have that really quite basic numbers. Or the other one is that you'll get like, oh yeah, you know, we'll run this line at a maximum of, you know, 20,000 cases a day or whatever. And you know that will never ever happen in a million years, but you don't know what the real answer is.
Sure.
I think I just had to pause on that as well. I think it's planning in the background as well. You see a lot of companies that expect a application to be up and running in 3 or 4 months, and without doing that type of work that Paul suggested in the data gathering, you need to spend a lot of time planning the application and understanding how the flow is going to work, and making sure you allow the time to implement an application. That with AGVs, AMRs, it is a longer installation period than a standard 6-axis industrial robot.
Sure.
And that does need to be planned for, and not expect miracles.
Yeah, you find yourself asking really strange questions like, can I take a photo of the underside of your pallet? Or, you know, can I just go and measure this random piece of wood that you're using for, you know, moving something? And they look at you really strangely, but, you know, that's your interface to moving the load, for instance. And it is that mindset change for them. And again, it goes back to what I said earlier about, you know, you watch a manual driver, all of this stuff just gets done up here really quickly.
Yeah.
But when you're trying to program something, when you're trying to write code to handle something, you need to know, you need to determine a lot of that stuff up front.
Okay, so
I think sorry, but Paul touched on a very, very important point there. It's the quality and the condition of the stuff that you're moving, the pallets that you're moving, to ensure that you have good quality pallets, that everything is relatively consistent. Because we do see issues sometimes where you can look in a racking and we've got broken pallets. All of this can be a challenge. So I think that's also important. Going back to sort of some of the environmental things, if you've got a lot of change and you've got a lot of things, certain navigation types might not suit that. So again, it's important to go with a broad mind, think, right, what suits this application best, rather than trying to go down one particular route. And again, that probably feeds into software and fleet management. If you've got 1 or 2, 3 AGVs, you might not need a complex fleet management. But if you've got 100, having a fleet management system to manage all those AGVs and how they interact with each other is critically important. So again, there's things to be considered there.
okay, so I've got some questions here from coming back. We can run through the benefits, I think, later, but we're talking about, somebody's asking about, you know, how do I begin to work out when the technology is right to invest in? ROI seems to be a hard area to give clients a factual answer on. And also there's another one here about, is it really justified? Is it only in modern factories? Are they only for top tier businesses, or can SMEs really afford these technologies? And I can understand these thoughts when we're talking about, you know, you've got to have the right pallets, you've got to have this, you've got to have that, you know, it's quite a big leap, isn't it? So George, what can you say then about ROI and the suitability to SMEs?
Yeah, so I think sometimes we get a bit blindsided, and I can totally empathise with people where they say or think that AMRs or AGVs, must not forget, or mobile forklifts are only targeted to top tier kind of massive end users. But we've got to remember that sometimes it is, at the end of the day, it's a transportation device, and it might just be something which is quite simple, which is carried out. If it might be in an SME that you still have a free shift pattern, and then quite quickly is that we start to factor in that this can run 24/7 or almost 24/7 when we can start talking about charging routines and things later. But is that the ROI generally maybe towards 2 years, depending on we're talking a bit about fleets as well, and for people which may not have come across fleets as well for mobile robots, this is when we've got like a collection of mobile robots working together for the same common goal, and we perhaps have a management system which dictates I've got a job which needs collecting from this materials area and delivering to this machine side. The fleet management system will go, this robot, all right, this one's available, send it over there. So it does get quite complex at times as to working out how quick it can pay back, and it's going to be a typical answer. It's going to be that it's application dependent, but the best thing is to really evaluate how much costs are going into doing specific tasks. And a lot of the time it's tasks which add no value whatsoever to the actual product that's being created as well. So is there opportunity to start producing maybe more of the product within the higher skilled tasks as well, to redeploy people on that case? But it doesn't have to be for very complex tasks as well. It could simply be moving a box. It could be using a transportation device with a simple trolley system almost, moving from one end of the factory to another. With it involved applications where it's moving. I think we had on a fleet of AMRs, each one was traveling about 40 kilometers per day. So that's a lot of time for an operator to be going back and forward all day. And that costs, when you start factoring these in, is that the ROI can be quite attractive in that terms and applicable to a lot of different customers, big or small.
Okay, I'm going to ask a question now. So with current labour shortages, surely the argument for these systems becomes even more worthwhile. What do you think to that, Andy?
I completely agree. I've been able to reallocate that resource to a more value-adding task. It's only going to be a benefit to the business. A lot of the tasks that we ask AGVs or AMRs to do are generally mundane, repetitive tasks. One of the things that we've done for our customers before is we've looked at their current process and even created a simulation based on their current process to replicate it. So then you can very easily add automation into that simulation to really see the true benefits of what you're going to achieve by introducing that automation.
So that's almost like a physical demonstration of operational benefits.
Exactly that, yes. Okay.
Other operational benefits. Matt, would you like to talk about any more? Or?
Just to say that also think of space as well. Particularly in the UK, factories tend to be short on space, particularly in SMEs. One of the things that I see time and time again when we go into places and facilities that haven't yet implemented AGVs or AMRs is we see a lot of work in progress around the assembly stations or process stations. And a lot of that is down to the fact that with a forklift truck driver, they will do things in batches. They will go and collect a batch of stillages or pallets and put them in a place, because you've got two processes. You either do that or you have just in time, which with a forklift driver tends to be just a little bit too late. And with an AMR or AGV, again, George was talking about 40 kilometers. And again, I guess the reason some of those numbers will be so high is because with an AGV, you can afford for that AGV to be continually going backwards and forwards, continually redistributing product. So you end up with all of the products where it needs to be, when it needs to be. And that's one of the big advantages that you have. So all of a sudden, all that real estate you've got taken up with work in progress can be redeployed for other things. That's one big advantage that sometimes people miss, the space saving that you have. And also, how important is it to make sure that that product gets from here to there in the right amount of time, so you've always got a product where it needs to be.
Yeah. Anything else? Does anyone want to add any more on the benefits that people should be thinking of? No?
Reduce product damage. So,
Yeah.
you know, go back to my manual warehouse days. You put a human on a bit of machinery and they get bored, they get tired. They'll, you know, there's the joke around the night shift. If there's any damage in the warehouse, it's the night shift's fault. So, you know, you put that on put that flow in an automated situation, and that then tends to, as Matt says, gets there in a timely manner. It's predictable, but it's less likely to become damaged. I mean, you know, the chances of it actually running into something is actually quite small. So there's a big one, really. It is product damage. So if you're moving something that's, you know, relatively valuable, automation is generally the way to go.
Okay, now I've got loads and loads of questions coming in, but if you just bear with me, I'm just going to finish through our bit and then I will come to them. We're coming now to what other technologies are required to support these applications, because you can't just, you know, get it out of the box, put it down and off we go. There are other things you need to do. So George, can I ask you first about other technologies that are required? Well, we've already talked about super fabulous Wi-Fi.
Yeah, absolutely. Wi-Fi, I totally agree with that. Is a major factor. For most applications, there will also need to be automation around it, whether that's installed on the robot itself. So again, I'm probably repeating myself, but it is a transportation device. So you might have a conveyor top installed on a mobile robot or an AGV. You might have some forklifts, or you might have some scissor lifts. It even might just be a locked cabinet with RFID, depending on the application or industry that you go into. So a lot of the time there does also need to be automation on the equipment itself, but also at the other end is when you're actually what the robot is interacting with as well. If we've got a product which is being delivered to line side of every machine, you most likely you're going to need something which is also going to take that product off of from the mobile robot as well. So which can be sometimes a hidden cost. So it's good to be aware of that as well. A few other things is, how do you want to think about kind of what dictates the job flow as well? What is actually demanding the robots to do tasks? You can set very basic systems where it might just be a push button from an operator to collect something, but you might want something which is a bit more fancy from a machine to request material maybe 5 minutes before it's about to run out. So there's a lot of kind of additional technology you can add to make things a lot more streamlined and efficient as well.
Okay.
Can I come in on that as well, George? So obviously we see a lot of customers with an ERP system, warehouse management system that's sitting there, and it might be 20 years old, and customers expect you to be able to interface with it. So a lot of the time what we actually need to see is some sort of middleware sitting in between our robot layer and the historic control system that the customer has, and how to extract that data. So that's, like George has touched on, generally a hidden cost that people don't even expect is required, but we need to be able to talk to systems to make it fully autonomous. So we need to be able to interface with whatever system the customers are using on plant, which does make another challenge. But
okay, well that's excellent, because someone's asked a question: when a mobile solution is delivering product to a line, do you need to integrate it into the machine control system when they are connected?
Some people start very, very, very simple with AMRs. So we've got lots of applications that don't talk to the line, that don't talk to anything, and it is just, as George said, a push button, and it's just an operator that calls for a part as and when they need it, or it's the warehouse pushing that part out to the line when they feel that they'll need it. But where you want to get with these applications is a fully autonomous workflow. So you want to get it to the stage that your control system knows that in 6 or 7 minutes time you're going to need product at station A, B, or C, and it's delivered just in time to that environment. So you can start simple and add the autonomy as you go, but some companies will want to start with a full kit and caboodle and start at the top. But you can do it both ways. I think the beauty of the AMRs is the adaptability, where you can start with one robot, you can then add more and more robots in. You can build that project up as you go. So we've got customers started with with 3 robots just delivering some material to a robot cell. Then they've added another 3 robots, which are then going to do trackside delivery. Then they're adding another 10 robots and then another 15 robots the following year. So they are slowly building it up, and they're gradually engaging with the IT team around it to create the infrastructure that's required. So that is really possible with AMR side of things. Again, I don't have any experience of AGVs, how that would be done, but from AMRs, the beauty is that adaptability.
Okay. Would anyone like to talk about adaptability of AGVs then in that context?
Yeah, I can take this. I think one of the things that, we've talked a lot, some mention of Wi-Fi, and there are instances where the customer just doesn't have the correct infrastructure. And this is again looking at the correct navigation types, because if we go with there are some applications where all we're doing is we are going around in a loop, almost like a train set, picking products up from A, taking it to B, going back round to C, D, and then back to A. And if we're doing that, we can simply use a magnetic tape, and at all the interface points, we can have RFID tags that give us an instruction. We can have radio frequency that connects locally to whatever it is, be it an automation station where we need some remote I/O or to open the door, things like this. So we can do things remotely. And this is what we were saying earlier about taking the right technology. There are some fantastic progressions in technology over the last few years in AMRs and even AGVs, but it's not necessarily right for everybody. So it's important to look at the wider portfolio of what's out there, what's available, because there may be things that are more suited to certain environments than others. It doesn't mean that the latest technology is necessarily the right thing. It's always fit for purpose. There are some fantastic advantages with some of the newer technology, but does it fit? Does it give you a return on investment? Sometimes yes, but let's explore it. And that's, I think, why the return on investment question is so difficult to answer, because there are so many different technologies and so many different applications. So what I would say is, let's take each individual case by case and look at it and see what fits best and how the investment fits. And then the other thing I would suggest, I think it applies to both AMR and AGVs, is good housekeeping. We say that AMRs have the advantage that they can go around things, absolutely, but quite often people use that as an excuse for bad housekeeping. So an AMR will always be more efficient if it has a clear pathway, and if it doesn't keep on having to avoid things and go around things. So if you can keep certain designated R's, and this comes back to training, making sure that people are aware, okay, right, I've got simple things like I've seen customers where they've painted a section of the floor so that it's a blue or green or whatever pathway, so that if they step on it or they put something on it, they go, the AGV is going to come past there, or the AMR is going to come past there in a moment. That's going to cause a problem. I need to move it. So it's just these general housekeeping that can help the process and help the efficiency of these products.
Okay, thank you. I'm going to move on now to safety considerations, obviously key in this area. And we've actually had quite a few questions. I'm scrolling through because there are many, many questions about, are the regulations keeping up with this new technology at the moment, or do you think there'll be changes in the future, or just someone take me and tell me about safety?
Given how long it took the last ISO standard to be agreed, I think almost certainly there'll be a change in the future. As to when, I wouldn't want to predict that.
I think one of the things that people kind of focus on, that people are always frightened from a safety perspective of new technology, but what we kind of forget is that one of the biggest causes of accidents in factories is forklift truck accidents. It's crashes with forklift trucks. If we can reduce the number of forklift trucks, which AGVs and AMRs will do, we by default are going to reduce the number of accidents, and that is we've got to look at. Yes, there are things to be aware of from a safety perspective, but an AGV or an AMR is its own safe system. So we've got scanners around it. It will stop if someone gets in front of it, whereas a forklift truck won't. And I think the people involved are generally people driving the forklift truck. So there's a lot of difficulties and safety constraints that we currently face that we accept as the norm. And what we're offering is something that will reduce those current level of accidents by removing some of the critical factors and limitations we have at the moment.
As the lift truck guy, Matt, I feel targeted now.
Yes, apologies to any forklift truck drivers. It's not a PPMA situation at all. I'm talking here about, someone did actually say it is a technology years ahead of the safety standards. If an accident does occur, how do you get a presumption of conformity to the machinery directive?
During the again, Matt's probably better placed to answer this, but I know for a fact that our friends at ABB have a technical file for each model in the range, and that sets out the. So if you take ISO 3691 Part 4, for instance, there will be a set of requirements in there, ranging from electrical requirements through to safety, I guess, architecture, but the behaviors that are required in certain situations and so on. That technical file basically outlines how the design has satisfied those requirements. And so that's one part of it. The other side of it is effectively, I don't know, I guess in software terms, we call it a log, but it's almost like a black box recorder. Everybody does this slightly differently as to whether, they record the LiDAR returns, whether they record, what the sensors are doing, what the code path has gone through. But at some point, there is a log of what happened. And so you then can piece together, at that time, the incident occurred, what happened there as well. So you can see what the vehicle was trying to think about. And then, of course, you've got the eyewitness side as well. So, in a previous life, not our own group, there was an incident that I heard about with a different integrator that a machine had struck somebody. And it was really clear that, they'd walked out into the pathway and the machine had, it had failed to stop. However, they'd literally walked out, within, less than half a meter of that vehicle passing. And so a log was pulled, as well as the CCTV was pulled. And it was really clear once you put those two things together that this person was actually on their telephone, which was a banned action at the time on that particular part of the shop floor. And they didn't check what they were doing, and they just walked across the pathway.
And if someone had done that in front of a forklift truck, chances are the same thing would have still
happened exactly the same way. Yeah.
Sure. Okay, so this seems to sort of point towards training. So George, you haven't spoken for a while. So I'm going to give you training. So I mean, they're obviously, with like most things, you need to make sure training is appropriate.
Yeah, I think Ross covered it perfectly earlier as well. Is the employee engagement is really key in a successful AMR, mobile AGV, anything mobile robotic application. One, just to actually make sure that the product does what it's supposed to do in the first place, but to make sure that people operate it around it safely as well. Yeah, kind of heard horror stories where people kind of almost jump from kind of machines above down in front of it, and then it's like anything, you can't stop instantaneously without any sort of stopping distance at all within there. So the best thing is to educate kind of the operators in a factory floor to say, this is the technology, this is actually how it works as well. Gather their interest, gather their thoughts on the technology being used. They'll know in certain scenarios as to where it might be a bit more of a challenge as well. So it's good to get that feedback as well from them too. But yeah, the best thing is just to be, I think, honest and kind of let them know how the technology itself works and how it works around them as well. Not that they have to, well, the idea is hopefully that they shouldn't have to change too much of their normal operation kind of practices. There might be a few little bits that need to change, but the technology is is built to work around them and be autonomous safely, as well as the product is intrinsically safe. That's the main thing. Unless something that's been integrated which is not done in a safe way, there's lots of safety parameters that can be altered, which is obviously an important thing to do. But engagement with the employees is one of the most important things.
Okay. Well, I would argue that would be quite motivating, actually, and exciting to have all that new kit in your workplace. But I'm probably just biased. We're just I'm coming on now to this raft of questions. So I think what we're going to do is I'm going to look for volunteers for some of these. Let me just start here. Right. So is an AMR AGV always worth the investment? Or are there limitations to consider, such as cost, labor / flexibility?
I think you touched on it earlier on, didn't you, with the shortage of labour is severe at the moment.
Yeah.
Obviously, each industry is really different. Each industry pays very differently. So investment, if it's worth it, we're always going to say 100% of the time, yes, it is worth it, because it's not just about the payback, it's about the safety, it's about the improvement in workflows, about the improvement in what that company can produce. You're becoming more efficient. You're getting to the stage then when, instead of the person that might be standing on the line for 3 hours and then going off and delivering parts and going collecting parts for an hour of their job, they're in that position for 4 hours. They're producing for that time, and they're letting the technology do the work around it. But for when it comes to value, non-value added tasks, AGVs, AMRs, fork trucks are absolutely worth it. We've seen so much since Brexit was announced, we've seen a huge drive towards robotics. But really, since probably obviously with COVID in the way, but since the last 2-3 years now, the push towards it and the inability to get staff, and after COVID, we've seen people don't want to do the same jobs they were doing before. We've really seen companies struggle. There's also always, we see a big system as well. When a very big home delivery service turn up at a town, they tend to take a lot of the staff from that town, and they pay a stupid amount more to keep those staff. And you always see a huge exodus of staff from warehousing and from from that type of delivery jobs that will leave overnight. So it's necessary at the moment. It's more about really the need to automate is tremendous, because the staff just aren't there, and the retention of staff is not there. When you bring AMRs in as well, we've got picking solutions where it would have taken customers previously 2 weeks to train someone to pick, and they can be trained in 2 hours when you're using an AMR system. It's not just the safety, it's not just the return of investment, it's actually everything else that technology brings to the application.
Sure. Okay. So I think the answer is yes, it's worth it. But the next one is, do you have any advice on how a machine builder can approach the safety concept when designing an AGV or an AMR? Anyone want to take that? Because I'm just going to have one person for each of these.
I think for that, for me, that's key. So when we were talking about safety before, and how safe are AMRs, they're extremely safe, but for me, it's what you're integrating into and the environment you're putting them in. So if you just integrate driving them up to a conveyor and transferring some boxes, sensor to say that it's in the correct position before you move the boxes may be sufficient. But if you're driving the AMR into a industrial robot cell, it's about keeping that machine safe when there's no AMR in the gate driving through, and it's how you approach that. And I don't think it's anything different from what we've historically done with general machinery. It's just approaching it in a safe way and making sure you've made all the safety considerations.
Okay, thank you. Now this is quite a specific one. I don't understand it, so I'm just going to ask one of you. Can you interface with external periphery devices to control the AMR/AGV to be more dynamic? For example, sim move.
I'm going to presume what that the question there is, can we change things dynamically? So, for example, we have an AMR or AGV that's going to deliver something to a certain point, and along that route, then it's saying, right, okay, now you need to come and now also go to here or reprioritize that AGV to something? So the answer to that is yes, it can, but again, it depends on the fleet management system and also the navigation type on how on whether you can do that. And again, this is where AMRs start to become a little bit more efficient, in that it's easier to redivert and send it or reprioritize and change that. But that's more to do with the fleet management software and the control system of the AGV than it is just the individual technology within the AGV or AMR.
Okay, thank you. Next one, does AMR get feedback from previous routes in order to be more efficient on their next task? Are they in a way smarter?
I'll take this one then. So again, look, exactly as Matt said, it all really depends on, I suppose, AMR to AMR, AGV to AGV. It differs from manufacturer to manufacturer on the software that's integrated into it. Yes, there absolutely are. So like fleet management systems which will learn and adapt. So you're probably hearing a lot about AI and stuff as well now, kind of being integrated into the technology here. So if an AMR was to go down, let's say aisle 6, and there's been a product that's been, or oil that's been spilled all over the surface, and someone's buried it off, or someone's just left a pallet in the pathway. The next time it can learn to go, okay, I saw that actually took way too long, and I actually even had to go back on myself to go a different route. There are software packages out there within the fleet management system which is learning to use this to make a more efficient kind of path planning for the next trip and so on. So it can go with this, and you can set kind of like a time limit to say, right, okay, I saw that about 30 minutes ago, I'm going to retry again now for the next time. But there is also things you can do as well from an operator point of view as well. So if you are closing down an aisle, you can signify that to the warehouse management system or the fleet management system to say, okay, this we're doing some maintenance work around this area. Please don't use this anymore and take a different route. So it's in the very nature of the way the technology is with the AMRs, and definitely the way it's progressing is to get smarter and smarter and to become more of a human brain to realise what is going on and work out better for the next attempt.
Okay, thank you. It says, can you expand on AGV's navigation? Do they use lasers, optical gyro, magnetic tape? What are the limitations of these options on AGVs?
I can do that one.
Yeah.
I'm going to give our standard answer from the panel. It depends on the application. So, I mean, for instance, the automotive guys like magnetic tape. Historically, they have done. And generally that allows them, they're constantly tinkering with their lines, so they can pull that stuff up and change it around. If you look at a much wider area, something like SLAM, or Geo-Guidance Natural Environment Navigation, that's something that has, very little infrastructure. You don't have to fit reflectors to the wall. You don't have to bury things in the floor. That works for quite a wide area and allows a certain amount of tolerance to changes in the environment as well. So yeah, the short answer is it depends on the application. The long answer is it depends on the application. Come talk to all of us and we'll guide you through it.
And there are occasions as well, just to add that, where sometimes dual navigation, so two types of navigation need to be combined to get the optimum. So magnetic tape, very robust, very reliable, and you can come into stations very quickly. But then wider expanses, it may be more beneficial to have some kind of laser visual guided navigation. So the ability, there are AGVs and AMRs where you can combine the two types of navigation to get the best of both worlds. So again, it's about looking at the environment. One of the things we mentioned earlier, very, very straight corridors with no features on the walls can create problems for AMRs and virtual navigation, whereas again, so navigation tape in those areas to avoid those kind of problems. So there's potential solutions to everything.
Okay, thank you. Right, now we're on to how are AGVs, AMRs protected against system failure can we connect an external device to remotely monitor them? Ross. I can see you. I can see you're itching.
Yes. So.
Oh.
Can you hear me? Yeah, our systems can be remotely monitored. We've got multiple applications that monitor robot movement throughout their journeys, to constantly monitor their status, their state, or even a fleet software every second. What you're doing? Where are you? What's your status? Where are you? What you're doing? What's your status? Constantly monitoring them. So yes, we can remotely see what's wrong with them. We can, if the customer allows, we can remotely access the robots, which is very hard in the UK. Not very many customer sites in the UK allow for remote access of robotics. That generally means that those robots are then connected to the internet. But it is possible. So we can remotely monitor. We can access and analyze what's going on during the robot's movement. And we have lots of additional third-party software to do that, or there's some software generally included in the robots. I think George touched on the AI stuff that's probably coming in over the next couple of years within all the robots. So I think what you have at the moment with maintenance monitoring is, once something does go wrong, it's then repaired and it's dealt with. What will come in the next couple of years is going to be probably the preventative maintenance. So the AI system is monitoring to see if there is a failure that might occur within the next 6 weeks or so, and then to signal somebody to get on site and to change that before that happens. So that's I think where we're going with that. But yes, at the moment you can monitor the system very easily.
Okay, thank you very much. Now I think we're going to be running out of time very soon, because it's 1 minute to 3 and we've got quite a few questions left. So what I'm going to say is, I feel sure that the PPMA will work out some kind of way of answering those questions and probably post them onto the BARA website, along with the press release and the recording that will be available. So I'm really sorry if we didn't get to your question, but they will be answered and we'll find some way of putting them on the website. I'm sure my marketing team are now loving me just saying that right now. Now, only for me to say thanks to the panel, and there will be another BARA webinar next year. And if you could, as I say, repeat to fill in the survey that will be coming up, that would be really helpful for us. So thank you very much. And thank you to the panel. It's been marvelous. Thank you.
Thank you.
Thank you.
Yeah.
Guys.
Cheers.
Thank you.
Bye.
Bye.